Okay, so hello everyone. I think it's the right time to start now. So welcome to today's session, HKU Programme Deep-dive session on engineering architecture. So my name is Nicole. I'm a student recruitment counselor from HKU, and I'll be moderating the session today. So I'd like to quickly walk you through today's rundown. So there'll be two presentations today, and after each presentation, there will be a short Q&A for you to ask any questions that you have for the program. You can speak to the speaker directly and ask him any questions. And if you still have further questions on general application, such as the application timeline, etc., then you're welcome to stay behind to talk to me. I'll be here for around 15 to 20 minutes. All right. So before we start, I'd like to show you a message from our Vice President and Vice Chancellor, Professor Ian Holliday.
Hello, I'm Ian Holliday. I'm happy to welcome you to Hong Kong U. We're already looking ahead to the first semester of next academic year and what we're going to be doing for teaching and learning when you join us. We know that this summer we can return to face-to-face teaching on campus, and that will be something of a trial run for the main semester, semester 1, from September through to December. We're confident then that we can also do a lot of face-to-face teaching on campus. Of course, there'll be some hybrid teaching. Some of our teaching will stay online because our students and our teachers have been very happy with some of the online teaching that they've had from us in the last few months. So we'll keep those best bits, but we will also bring you all on campus. There will be face-to-face teaching, and you will get a great educational experience here at Hong Kong U. So I'm looking forward to seeing you in September, to welcoming you to the campus, and to joining you as we reinvent our campus in the new semester.
Okay, so now I'll pass the time to Dr. Kevin Tia, who is the Program Director for the Biomedical Engineering Program. So Kevin, please take over.
Thank you very much. All right, so hi everyone. Let me show my screen first of all. Here. All right, so make sure you can see the screen. I mean, if you have any problem with watching the videos later on, or any problem, just raise your hands or ask me questions. Okay. So now let me just quickly walk you through what you are going to expect in the following less than an hour or so. I'm going to give you a very brief overview of first of all what biomedical engineering is about, okay, and I will quickly go for some of the features and characteristics of our BME programs, and that probably would take about 30 minutes, and then I would actually pass the time to one of our alumni here, Dr. Matthew Tang. So he actually graduated in 2011. So and he is now actually working in a startup company as a core member, developing some very cool technology. So I think that he will be talking more about his experience over the years, especially during the years in our program and also afterwards. Okay, so let me just quickly go through like in general, okay, what the biomedical engineering is about. I think that I think most of you might have been hearing a lot about the biotechnology and biomedical engineering, how they have been impacting our society in general. Okay, so first of all, okay, let me pull down a little bit here. Okay, so in general, all right, this is actually the quote that I directly, copy and paste from our website. So this is pretty much like a very formal but boring statement here. Okay, what biomedical engineering is about is to apply something that we can control, like the analysis, engineering analysis, to understand the inner working of many different types of living system, including human. Okay, and how do we do that? So let me just walk you through several examples from humans into something something smaller, down to something extremely small, down to the biological cells. Okay, so let me go through first of all here. So in biomedical engineering, we will run into many problems at how we can understand different types of signals that we can generate from our body. Okay, and what you're seeing in this video, it turns out our muscles, okay, can actually generate the electrical signals that we can make use of, okay, to control, you know, certain types of electronics or instruments. Like if you put on any different gestures, okay, and combining advanced, you might be very familiar with nowadays, the deep learning algorithm, then you can recognize these different types of electrical activities. Okay, how do they correspond to different gestures? So you can use this different types of gesture to control machines. Okay, so this is one concept that you can, by understanding, okay, the human physiology, okay, and make use of this concept to control electronics or instruments. Something smaller, okay, perhaps a little bit more remote from human, but I think this is also one of the very cool technologies and one of the breakthrough in the biotech in the recent years, is that nowadays people can actually use light, okay, like laser, okay, to control animals. Okay, sounds a little bit scary, but what you're seeing here is indeed something happening right now. What you're seeing here is within this box, okay, this little rat, okay, it's actually put with a little optical fiber, which is as thin as a human hair, sticking out from its brain. Okay, so the scientists managed to deliver the light through the optical fibers to the brain such a way that I can very precisely control a very precise part of the brain. In this case, it's the mouse or the rats, okay, so that you can control the motion. For example, what you're seeing here, like this rat is very disciplined, running in an anti-clockwise manner when the light is on. So maybe you can see it right again. So right now the light is off. Now the light is on, then it's pretty much controlling the mouse. It's actually going along anti-clockwise manner until it stops. Okay, so this is really something that we are able to do it right now with the current technologies, and the underlying applications is that now we can use this this technology to understand how brains actually works. Something even smaller, okay, so nowadays you can have many different advanced microscopy techniques, okay, like very advanced microscope, okay, to look at something very small and with great details. So what you are seeing here is it's an image, okay, of a fruit fly, okay, and what you are seeing is basically an evolution of how the fruit fly embryo developed all the way to an adult. And the little dots that blinking throughout the screen are basically the individual cells. So nowadays we can use this technology to track, okay, individual cells within the fruit fly. And what we can do with that is now we can use this animal as a model to understand how the animals actually develops from the very, very early stage all the way from the embryo to adult. So that actually gives a lot of new insights to the human physiology and also diseases. And even smaller scale, okay, you can even look into down to individual biological cells. What you are seeing is a very cool video. The red object is actually a red, the white blood cells, okay, which is now attacking a cancer cell. So everything that you are seeing is actually in real time in action. So nowadays people can use this methods, okay, to monitor how our immune system, for example, okay, to work out the immune system properly, and how it actually fails in some of the disease conditions. Now, to bring it to the next level, the biomedical engineering, okay, not only this, as I said, that would use this technology to understand the inner working of different types of a living system, but based on this knowledge that we can develop new solutions to address the many unmet needs in biomedicine, especially the healthy aging, okay, or in general aging problems. So what you're seeing here right now, okay, it's a general trend of the aging populations and the projection from now all the way to 30 years or even in a half a century later. You can see that this is pretty much the global populations on the planet, okay, with the age of 60 years old. Okay, so you can see that starting from like 2017. So you would expect, 30 years later, we will basically have a double of population. Okay, we will have a population doubled, who will have the age over 60s, and you can project this even to a larger number in the next 20 or 30 years later. Now, and the underlying implications, okay, is that first of all, every one of us here would have a better chance to live longer than our older generation. But on the other hand, we have a lot of problems that we have to deal with as we live longer. For example, we would have a higher risk running into many different types of chronic diseases. Okay, so let me just go through one of the hardcore evidence that you can see that in this chart, okay, showing you the global causes of death. Okay, this is a little bit old data, 3 years ago, but I mean the general trend is pretty much the same. That you can see the top cause of death here. It's the cardiovascular diseases. Pretty much refers to any disease related to the heart problems or blood problems. Okay, and how does that actually relate to aging? If you look at the so-called risk factors, meaning that what are the factors that would run into possibly the cardiovascular diseases. So these are basically some of the main factors that you would expect. Okay, for example, smoking, hypertension, meaning high blood pressure. Okay, diabetes on a high glucose level, being too fat. Okay, and also lack of physical activities and chronic stress. For every single day, especially for people in civilized city. And you can see that all these problems are actually related to our daily lives experience, our lifestyles, especially getting more and more severe as we are able to live longer. Okay, so that's actually why I would like to show you one particular example of how biomedical engineering would play an important role to address this problem. So especially how we diagnoses the heart problems. Now, before we go on, I think that someone actually asked, okay, so just to say hi. All right, so let me just go through some of the examples and how the biomedical engineering would play the role here. In fact, I'm not sure anyone would try to ask me at this point, okay, wait, now you just talk about, okay, cardiovascular disease is one of the problems. So what about the COVID-19? Everyone is talking about every single day right now, okay? So let me just have 1 minute brief summary here. What I would like to show you, this is actually the very latest statistics showing about the global death, okay? This is actually the number of cases per week globally, and comparing with all other cause of death that I showed in the previous slide, putting all together. Then you can actually see that, okay, it seems that the COVID-19 indeed rising to a pretty alerting level, showing the very high level of number of deaths per week. But I also would like to draw your attention to the fact that the plot here is actually missing something that, especially the top two cause of death items, which is the cardiovascular diseases and cancers. And if you actually go dig into the figures, and you will find that in fact, and the numbers are actually still quite well beyond the COVID-19 global death cases. And if in fact the number is here, it's so high that if I try to rescale everything, okay, then you would see that the problems of the cardiovascular disease as well as cancer is still one of the major causes, at least as of today, okay, the major cause of death. Now, of course, I mean, don't get me wrong, I'm not trying to downplay the significance or the seriousness of the COVID-19, but the flip side is that I also want all of you here to be aware of many other problems, medical problems or health problems that would need many innovations or biotech innovations developments to solve the problems. And that's exactly what I would like to show you in the next slide, next few slides, back to the cardiovascular diseases here. So especially looking into now, I mean, cardiovascular diseases consist of many problems. One of the major and very critical problem is what we call the coronary artery diseases. So this is in general, this is a very serious problem in one of the major blood vessels in our heart, which is called a coronary artery. So that is the problem when the blood vessels get blocked, especially by the fatty tissues. And in that case, okay, you would not allow the blood flow in a very smooth manner. And if that's the case, the blood flow stop, and then you would be run into a very fatal problems. Okay, this is what in general public people call the heart attack problem. Okay, so in general, how people nowadays would use technology to do diagnosis. Okay, first of all, I think maybe some of you might have gone through the test before, this test called the ECG. So this is a technique that's very similar to the very first example that I showed you, measuring the electrical activities from muscles here, but not our skin or our arm muscles, but it's actually the electrical activity generated from our hearts. All right, so you can use the signals as an indicator to show whether or not the heart is actually functioning well. Okay, and other example, okay, you can use so-called medical imaging technology. Okay, and one of the most commonly used one is called MRI. I'm sure a lot of you would have heard this technology before. And by using this technology, you can visualize, okay, pretty much the whole body functions in this case, and you can clearly see in this video how the heart's actually pumping blood in and out, okay, from the hearts very clearly. Now, but if you try to look back to the problem that I just mentioned about the coronary artery diseases, so this is about the problems within the artery. So none of the methods that I showed you that before, like the MRI or ECG, are showing exactly what's going on within the artery. Now, and if you try to understand the problem, now this is pretty much an example or exercise that I can give right now to show you how we normally in biomedical engineering would try to solve the problem. You have to identify the problem here, which is, now the coronary artery is something very small, which is talking about like a few millimeters. So if you want to know what's going wrong within the blood vessels, you really have to have something to image them, or you have to capture the image or videos, okay, within the blood vessels. But if you actually look into some of the current technologies nowadays, especially if you want to look at something very small, microscope would be one of the options. But definitely, if you look at the size, they are just too bulky, too big to be put within your body. Even not the case for the camera itself, because the camera is still something pretty bulky compared to the size of the artery that we're talking about, okay? And even if you talk about just take out the image sensor within the camera, okay, this is still something relatively bigger than the artery. So none of this method would be able to help us to clearly visualize what's going on and what's going wrong within an artery. So there's some technology which is called a micro endoscopy. Okay, this is you can think of a microscope but made of something very flexible and something very small. And one of the materials that people nowadays would use is the optical fiber. Okay, so this optical fiber is a very thin object, okay, as thin as your human hair. Okay, and you can think of now, I can use this optical fiber, okay, to do more like a radar scan in any lumen structures inside the body, including the blood vessels. So by doing so, okay, this kind of radar scan, you can capture the image, but within a very small area of interest. Okay, and indeed, this is something being practiced already clinically right now in many hospitals. Particularly used in the cardiovascular imaging, meaning that you can put this device, optical fibers, literally into the heart, okay, into the blood vessels. So what you're seeing here is actually a video But for the interest of time, maybe I can play these two more videos on the right-hand side just to show you what you are seeing here is a little fiber, okay, just like on the left-hand side. You can imagine this little fiber, it's navigating within the blood vessels. This is something that people manage to do that right now routinely and clinically. Then you can image not only the blood vessels wall, but you can look into the features or the tissues beneath the blood vessels wall. So you can clearly visualize what's going on within this tiny vessels. And people nowadays can even use the computer, the computational algorithm, then you can visualize very nicely in three-dimensional, okay, how the coronary artery looks like, especially before and after a very important surgical procedures relevant to the coronary artery diseases, which is the process that the surgeon, okay, would put the stent implant inside the coronary artery in such a way that you can enlarge the blood vessel wall so that you can let the blood passage go smooth again. Okay, so using this imaging technology, so you can monitor if the surgical procedure is doing right or wrong. Okay, so this is what people nowadays routinely use this technology. Now, and you can actually see now, I mean, what I just showed you in the previous few slides is pretty much like a tip of the iceberg of many different types of biomedical engineering technologies or biotechnologies. But in general, okay, or traditionally, what people are thinking about BME would be the scenario that the medical doctors or the clinicians, have certain problems, okay, and they would ask for solutions from the engineers. Okay, indeed, this is pretty much what we have been perceiving the role of the biomedical engineers. But I think would be more important nowadays, you have to think about how by understanding biology, by understanding the medicine in general, okay, to innovate new technologies. One of the example is just like the very first example I showed you, you can make use of the electrical activities from human, okay, to control instruments. So this is something that you can have a new insights in engineering. And by inventing new technologies, you can provide new discovery in the biomedicine, just like what I showed you in the first slide again, like using the light to control the mouse brain, okay, then you can understand how brain works. So you can actually see that in biomedical engineering, in this case, so it involves many different disciplines altogether. And indeed, in our program, this is really what we've been focusing on very, very intensively. So in terms of our curriculum design, okay, based on all these considerations, and we designed the curriculum that would involve the interdisciplinary training, especially in the year 1 and 2. Okay, we would make sure the student would have a very strong foundation in all mathematics, engineering aspects, so including electronic and also mechanical engineering, fused with the knowledge of the basic or foundation biomedical sciences. So these are the topics or areas all of our BME students would go through in their first 2 years. Now, I mean, in our programs, and we have a lot of our teachers and who are in their forefront of expertise. And here again, just highlight some of the key areas that we are particularly strong. For example, the technologies in eye treatment or surgical treatment, the regenerative medicines, and also the medical imaging technologies, also and also some of the latest technologies relating to the gene editing. This is also something that a lot of our teachers are in their forefront of expertise. So, and talking about our teachers, I mean, they are actually coming from both our faculty of engineering and also the faculty of medicines, and making use of this very strong synergism between the two faculties in research. We try to bring this advantage, okay, to build up an interdisciplinary learning environment to our BME students. So this is really one of our key characteristics of our curriculum, that we bring the synergism between the faculty of engineering and medicines together, Especially, you would appreciate more when you go to the senior years of study, particularly in year 3 and 4, during which the students would be able to choose their own interests of expertise in many different aspects. So here are the 4 main aspects that we will focus on. For example, the biomaterials or tissue engineering, the biomechanics and transports, and different types of biomedical imaging technologies, and also the genome science and bioinformatics. And in our program, we have been also focusing a lot on the hands-on experience in many different our courses and projects. So what you are seeing here, I pick up one of the examples. This is one of the signature courses in our program, okay, in which that the students are asked to build a medical device. This is a functional medical device, almost from scratch, for the course of 13 weeks or so. So, and here, right, what you're seeing, okay, is a very fun event that we are having every single year during the course. That once they build the student build their system or the device, okay, we are going to have the so-called drop test. So it's what you are seeing here is, okay, the gentleman on the left-hand side is actually myself, all right? So I'm actually the teacher of this course. So the whole idea of this drop test is to let the student understand not only the need to make a medical device, but you have to make a robust and functional device. And you can see that, they're having fun. Okay, not only this course, we have many other courses that would involve heavily many laboratory sessions, and thanks for many available facilities both on our engineering campus and also the medicine campuses. Some more other hands-on training experience. Okay, we are also encouraging the students to go for the summer internship, especially during the summer to year 4. Okay, and they will have a chance to go for internship in local hospitals or local biotech companies, and even some other research institute, not even in Hong Kong, but globally. So they will go through an internship for the course of 6 to 8 weeks. Okay, so this is one of the sort of compulsory requirements to fulfill the course requirement. And towards the end of the year, so we will have this so-called the capstone experience. So each of the students would be handling a very specific topic related to BME and supervised by a supervisors in engineering and the other either from the Faculty of Medicines or the hospital or even from the local industry. Of course, related to the biotech developments. So during the whole year, the student would work out the problems to solve a particular, work out the solutions to solve a particular problems related to some pressing needs in the biomedicines. Okay, and actually back to year 1, all right, this is really something new that we just started last year, especially and exclusively for our BME student year 1, that we realized that in the very early years, it's very important to let them have some initial taste of what's the real world biomedical engineering research about. So we have this so-called lab shadowing program that the student would have a chance to rotate between different labs over by our teachers in BME so that they can work under the shadow or behind the shadow of some of the PhD students or senior researchers in our different laboratories so that they can get a taste of what's going on, okay, in the real world situation, even though they might not have the very hardcore concept yet, because this is still early years. But I think this is a very well received activities, and the students like it very much. And I think that we are going to continue on in the following years. So let me see how much time. Oh, okay, that's a pretty good timing. So talking about it, those the opportunities that you would experience is pretty much like inside a classroom or within the curriculum. And in fact, outside of a curriculum, and there are many other opportunities for the students, okay, to experience more about the medical engineering. Okay, for example, the overseas exchange inside within our university, we have this undergrad research fellowship programs, that would encourage for those who are very motivated to go on for further study in biomedical engineering research. These are the programs for those students. And we also have a very strong connection with the local biotech or biomedical device industry, and they actually provide us this type of mentorship schemes, so that the students can have a chance to talk to some of the industry people who are in the hardcore biotech development, so that they would get exposure to the real world and the BME situations. Many other opportunities like different competitions. Okay, here I just list out some of the recent awards that our students got in the past 2 or 3 years. And in general, I have to say that a lot of our students in our BME have been doing very well, and I think this is what we have been treasuring, and I hope our students will continue on having this motivation or inspiration to go on for more opportunities. Let me see if so anyone couldn't hear me right now? I heard some of you said you can't hear me. All right, I think still okay. If no, I think I can continue. Just let me know, okay, if you have any problem. All right. So I just have two more slides. I think also what you would be also interested in knowing more. Okay, what's the career prospect of BME? Okay, so here I highlight some of the most common pathway based on our experience. And I can tell you that over the years, we have a pretty a big portion of students, okay, would go on for further studies, either in Hong Kong or overseas. So these are some of the schools that you can recognize, the top universities overseas, and they went for master degree program or PhD degree programs. And I also highlight, here some of our very distinguished, alumni, who are now the academia as faculty members in the universities here in Hong Kong or overseas. Okay, so I mean, if you have chance to join us, I mean, you probably in the future will be one of them. And there's another pathway that our students actually went on after the graduation, which is going for further study in the medical school, particularly the overseas. We have several cases in the past few years that they feel that they are aspire to be like a medical doctors, or they want to be practicing in the in clinics. So having their expertise or the knowledge that they have gained in BME, they feel that they want to go for those areas. So this is something that is possible as well. And there's another current trend I think that I have been seeing, especially in the past few years, is that a lot of our students also aspire to go into entrepreneurship, meaning that they want to turn their own idea from their projects or their thesis into some real commercial products, okay, that could impact the healthcare or some other area related to biotech. So here are some of the examples, and I think that one of our alumni today, okay, Matthew, he is actually working as a hardcore member in one of the startup companies, and he will be share his experience later on with you. Okay, so of course there are many other opportunities. So here I'm not going to go through very detailed, but these are some of the major medical device companies or medical instrumentation companies that our students have been getting the opportunities to work there. And also a lot of the local hospital, either the public or private hospital, they also have the opening, especially the medical physicists trainees. Okay, they are now have more and more openings in the past 2 or 3 years, especially targeting our BME graduates. So these are the emerging opportunities that we are seeing in the past few years as well. Okay, so probably I would stop right here. Okay, and I think that within half an hour it would not be possible to explain every single detail, but I do encourage you to actually visit our website, which is shown here, for getting more information about our program, the curriculum, or some of the characteristics, and also our recent news. Okay. And perhaps I would stop here, and I would actually pass the time to Matthew, okay, who is actually our alumni, graduated in some years ago, okay. I'm not meaning anything here, okay. Still very young, okay, very young talent, and I will pass the time to him and talk. Maybe I can let him to explain about, share with you more about his experience in the past few years. Okay, thank you very much. I'm sure you can see your face.
Okay.
Yeah.
All right. Yep. So hello everyone. So my name is Matthew, and I am a graduate of the medical engineering program, the class of 2011. So I would like to share some of my past experience during my bachelor studies, and also some of my exposures and what I've done in recent years. So I think first of all, like why I would choose the medical engineering program is that I always like the seeing the problem of medical issues or human health. So that is one of the major idea that I want to go deep into. So that's why I choose the medical related major. And the other thing is that I always like to do some hands-on work. So I think engineering is one of the subject that you can do lots of hands-on work and gain experience doing that. So that's why I have these two ideas in my mind, and I choose the medical engineering program as the obvious option. So I think during my 3-year studies in my bachelor, so I gained lots of insights on like life science or human-based knowledge, and also on the engineering aspects of the knowledge, such as the electronics or the mechanical part of it. So, and I would like to share like one of the exciting moments that during my studies as a bachelor student is that we have a project that we have to do the hands-on experience on building a ECG. So ECG, in layman term, is a device that you can measure the patient's heart rate, or even see the waveform of the heart rate. So because as a normal human, we normally feel our heart rate just by putting our hand near your heart. So you just feel that pulsing effect. But what can be more is that we can see what is actually hiding behind these pulses. So we can see the waveform of it through the ECG machine. So during the course, I have to learn the basics of the theory of what's included in the ECG device. And during the learning process, I mean, we have to go through the learning curve quite a lot. So the exciting moment is that when you are holding your handheld device that is built by yourself, and you are actually seeing your heart rate beeping on the monitor. So that is like the very exciting moment that you can see, because you are building from scratch of some electronics components from all the way through to get the your heart rate. So that is one of the things that I think is the coolest thing that I have experienced during my bachelor study. And afterwards, I am thinking, so what's next? So if there is a chance that I can learn more, so why not? So I decided to go to further studies overseas to gain more exposures in the biomedical engineering. And by that time, I learned more about the more smaller scale stuff. So that is like the cell biology stuff. And I studied a master degree overseas. So after that, I returned back to Hong Kong to do my PhD studies here. And I work on the microfluidics technology. So which is, we're trying to study the fluid inside a very small scale. And the size of scale is the order of magnitude of a hair. So what we can do, or what we can apply this technology, is that we can use this technique or the theory to understand what is the fluid or the blood pumping doing or inside a human. And after I graduated from my PhD studies, I joined the startup company Concept and work as a core member to further develop my technologies on microfluidics and try to use that as a very small device to try to check the patient samples, or specifically the cell samples, what we can get from the patients, and we can check what's inside of the cells, what's the cells inside, and pumping through this device, and we can check all the cells in a very high-speed manner, and by that we can define, or we can check what's actually what's the disease that the patient is getting. And yeah, I think this is some of the experience that the biomedical engineering programs can give me, and what shapes me of what I'm doing and what's exciting part about today. So thank you.
All right, thank you very much. And I think we have some time right now. I mean, if you have any questions for me, and also as well as Matthew here, feel free to ask us right now. And I think that you feel free to just speak up through a microphone if it's possible, or you can just type in and then we can read your question too, and then we can answer that. I think we have around probably maybe 10 minutes or so. We can hear any questions from you. Any particular questions you might want to know, or you think that I've missed any point? Let me know. And this is a very rare chance that you can talk to us here directly. So make use of this chance, and and you should be more active too, because this is really pretty much what you should expect from the university learning experience too. Okay, if you don't talk, then your teacher won't talk. That's true. Any particular question? Okay, so I got some questions here. Okay, is BME closely related to neuroscience and brain-machine interface? So this could be one. This is actually one of the areas that we are having in some of our course materials, as well as related to the research expertise in by one of our teachers, professors here in our program. So this is not just the only one, all right? Not the only area that our BME is closely related to. So apart from neuroscience and or the technology that you can apply to accelerate the neuroscience research development, but more other areas, as I mentioned briefly before, like other types of biomedical imaging technologies, including ultrasound technologies or optical imaging technologies. Apart from that, we have areas, we have a number of teachers and professors working in particularly in the expertise in the tissue engineering or regenerative medicine, on the other hand. So these are the areas that we are particularly strong, I have to say, in the past few years. So, and we develop in here in our university different types of technologies to address some of the challenges in these areas. I'm not sure if I answer your questions. Let me know. Okay, you can further, follow up your questions. Prosthetics part of the is prosthetics a part of the BME? We do have some courses, related to biomechanics. Okay, and definitely this is a core or a fundamental knowledge that would be related to prosthetic related technologies. And actually, having said that, I can also briefly introduce another professors in our program, which is also our core teachers for many years, Professor William Liu. Okay, and he and his research team in a few years back, and they actually had a startup company making different types of prosthetic devices related, or implants, I have to say, as a startup company in Hong Kong, and they are actually having a multiple clinical trial here in Hong Kong, as well as multiple areas, multiple cities in mainland China. So yes, that is actually one of the areas that we you would expect to learn in our program, and you would also have projects. You would expect some projects, over by Professor Liu on this front. Okay. Hope that I would answer the questions. Any other questions? So, all right, I want to ask if I should take BME if I'm interested in AI and biology. Now, since you are in this chat room, of course, and I would say that you should take BME, okay? But of course, you also want to look into a broader aspect of how you think the combination of AI and biology would help. I could say two very different perspectives. For example, I know some of the computer science students, they are very interested in AI, and they are also very interested in the biology, but they are more into developing algorithms and computation tools, okay, to help the problems in biology. So that could be, okay, one option that you might want to get more exposure in computer science. But on the other hand, we also have students, who are more interested in the biomedical science aspect, okay, of applying AI. And for example, the gene editing technologies I briefly mentioned, which is also the expertise of one of our teachers. And he is also affiliated with the Faculty of Medicine. And but his research team has been working heavily on different computational methods, but in his lab, okay, together with the students and including some of our BME undergraduate research students, also working in many biological experiments, okay, that you can combine these AI together. So the exposure is very different. So if you want to know more, I can actually talk for more than 10 hours. But I think that if you really want to know more, I encourage you to come and talk to me, maybe through emails, or we can talk further. Okay. All right. So do I need to learn some programming in BME? Yes. Very, very true. Although we don't have very extensive training to cover many different, I'm not sure you understand or you realize that there are actually many different types of so-called computer programming languages. But there are quite a number of them, and we in our curriculum, especially during the year one, we will have a common engineering course in sort of computer science, in which that you would learn the essential concepts in computer programming. Because in the later years, of course, depending on different expertise, you might run into the problems that you need the knowledge in programming, especially if you get into the bioinformatics expertise. Okay, so is this major 4-year or 5-year? This is a 4-year program, okay? Unless you opt for double degree, then that will count. That would account for additional year. But normally, if you have declare one major in BME, that's a 4-year, okay? All right, is BME specifically designed for humans or other further study or in light of animals? In terms of the curriculum, I think we cover every aspect, okay, in biomedicine and life science research. So in that sense, it will cover basically the biomedical sciences in both, you know, human, animals, models. Okay, let me see how much time we have. Okay, so we have probably 1 or 2 more minutes, and I saw some people in the internet saying the students are better than learn double E. Well, it depends on what forum or platform that you are looking at. Again, okay, if you are here in this chat room, I have to say that the other way around, but of course, depend upon the again, the expertise of what you are looking for, especially after graduation. Okay, for example, in many of our BME graduates, okay, they might opt for the training opportunities in some of the biotech companies, and they might not need, you know, any, you know, triple E or double E training at all. For example, I mean, we have some startup companies here in Science Park that might be more into tissue engineering, and definitely this is not something you can learn from double E. So it's really depend on what area that you are looking into. So I hope that would get your question answered, but let me know. If any other questions. Okay, now I think if there's no more questions, probably we can conclude the session here. But if you have any more inquiry, perhaps about the mission requirement or other technical details about the program, feel free to talk to me. You can find my contact information online in the website. All right. So I think that's it for today. And thank you very much for your time, and happy to talk to you. Thank you.
Thank you, Kevin. So just like what Kevin just said, I think you can easily find the contact information for like where you can find Kevin, how you can contact Kevin. But just in case, if you can't, I'm sharing the link here. So it's just a centralized link for you to submit, you know, any inquiries you have. So if you can't think of any questions for the BME program now, but you have some in the future, then you can send it to us, and then we can sort advice from Kevin, and then, you know, get back to you. Okay. So thank you, Kevin, for your time today, and
thank you
for your very insightful sharing. So thank you. Bye bye.
Bye bye.
Bye bye. Okay, so now we still have a few more minutes before the next session begin. So perhaps I can, because I know some of the students here, they are non-JUPA students, so maybe I can share with you a bit on how you can make a HKU application as a non-JUPA student. So hold on. Sorry, just give me a second. All right, so for the non-JUPA students here, we're still taking your applications. If you're thinking of applying to HKU but have not, you can do it until 15th of July. So in each HKU application, you can choose up to 5 programs. In one, by submitting one application, you can apply to a maximum of 5 programs. And then we do offer you multiple offers, meaning that the programs, they will review your application separately. They will interview you and assess you individually. So it is possible for a student to have more than one offers. So based on your application materials, and if you happen to have more than one offer, you can just pay deposit once to accept all the conditional offers. And after accepting all the offers, you don't really have to confirm which one to take finally until you have your IB. For example, when you have your IB score or you have your final results. Okay, and a lot of people are concerned of scholarship. Or in HKU, we are very convenient, so you don't have to apply for scholarship separately. You can simply submit an application to us. Submit an application to us, and then if you are eligible for any scholarship, then you'll be notified when you receive your offer from us. Okay. So I think now the speakers for the next session by architecture, I think they're ready. So let me just check. So Dr. Zhou, if you're ready, you can take over. Yes, thank you. You can take over the screen.
Great. So good afternoon, everyone. We're starting promptly on time. Maybe I just share my screen very quickly?
Yes, please. Yes, please.
1 second. So can everyone see? Let me introduce myself very briefly as we're showing a poster for today's session, which we have called Futures Before, During, and After. Firstly, I wanted to introduce myself. My name is Ying. I'm an assistant professor at the Department of Architecture, and I'm also the admissions tutor for the Bachelor of Architecture and Architectural Studies program. I'm going to be kind of present throughout the session, even though there will be a number of speakers from the department who will be joining me. So firstly, I wanted to set the framework for today's 1-hour session. Because of the current events, we're very unfortunate to have to do this online. It's very much not the same as being in the same space, kind of informally sharing a bit of what we do at the Department of Architecture, what our program is like, what the spaces are like, and what our students actually do in the studies. As most of you know, physical spaces are our specialty. And of course, in lieu of what's happening, we decided to program today's session using the technologies that we have that bring us all together in a virtual setting into 3 larger panels. Namely, we wanted to kind of break down the panels to talk about 3 topics. So from 5:10 onwards, we might start a bit earlier since some of the sessions might be a bit longer than others. We'll be talking about what is architectural studies with Eric Schuldenfrei, who's the head of the department, and Eunice Tseng, who's one of our associate professors in the architecture department. We'll also be having a second panel, which will be talking about why is Hong Kong U a great place to study architecture. We'll be joined by a number of students, by Cheryl, by Wesley, Amanda, and Phoebe, whom you will later meet. There are current students from different parts of the world, and they will talk a little bit moderated by Roberto, who's one of our teachers and my colleague, who you can see waving at you, about what it's actually like to study architecture here in the present. And then we'll end the panels with a bigger, not a bigger session, but a session that we've called What is the Future After the BAAS? We'll be joined by Michael, we'll be joined by Susie, we'll be joined by Eagle, and we'll also be joined by Sue Chang, who are our former students who have gone on into the world, and they'll be telling us a little bit about what they have been doing since they've left Hong Kong U and their ventures. And this panel will be moderated by another colleague, Thomas Sung, who will be sharing also a little bit with you about this bigger community that we have all formed. I wanted to thank, of course, everyone who have joined us, as well as the team that has made this possible from both the department and the Faculty of Architecture, as well as HKU's Registry. I wanted to also introduce a bit the logistics. Basically, each of the sessions will take about 15 minutes with the panel that will exchange on a number of topics that are within each of the panel headings. And we'll end the last 5 minutes with a session where audience can write in with their questions. So I would ask all the audience, future students, also parents who may be joining us, to please write in the chat to me. You can find my name under YZHOU with your questions. And I will be selecting a few of probably too many questions that we can answer in the short framework that we have. And then we'll open the panel to discussing a number of these questions. Of course, we will always be open to all of you should you have questions after the session. Usually with a physical session, we have the students, the teachers, and the audience coming together in a very informal way, which we try to, in a way, replicate in virtual space now. But you're always welcome to write in with your questions after. So perhaps we can start with our first two speakers. Let me just try to, so I would like to introduce Eric and Eunice. Would you wave? Great. I don't want to say too much, but Eric is our head of the department. In fact, he was once my teacher as well. He's been an educator and a practitioner for more than a few decades, is it? And he will be in a conversation with Eunice, who is also very much a mentor for myself as well, and a teacher and practitioner for a number of years as well. So I pass the mic on to Eunice and Eric. I will be keeping time, so I will let you know around the 10-minute mark.
Thank you. Thank you so much. And thank you all for attending this. It's fantastic to see so much participation. And also in such a world where we see a lot of each other on Zoom and not enough of each other in real life and communication. And it also starts to show the importance of physical spaces, that these physical spaces do tend to define how we interact with one another and how our interactions really are affected by the spaces that we create and the spaces we think about. So just briefly, I want to give an overview of the concept of the curriculum and what we really do. I can see that there's some feedback noise from some of the other, there we go. But maybe if someone has the ability to put on mute some of the other, just so that we don't have too much feedback. So what I wanted to do is also just give a little bit of background about the architecture, what it is that we do and how do we teach. And then really, as we set up this idea of how we participate into different conversations around the concept of how architecture reaches beyond just creating spaces. And architecture really does have a deep-rooted sense of nature within the culture of a place, and also a deep-rooted sense of how society builds and forms around us as well. And one thing I just want to say from the very beginning, and maybe I'll share the screen as well. Actually, can I share the screen? Can I be made a co-host by whoever has the hosting rights? I just need to be made a co-host before I can share my screen. And so in this,
Eric, you can share a screen even if you're not a co-host.
It says a host disabled participant screen sharing. Yeah, now I can. Thank you. So I just want to share that there is a prospectus that's online. And this prospectus is a really great resource because it sort of encapsulates what we do within architecture and how we both work within the context of Hong Kong U, but also expand and go beyond the university as well. So this is available online, anyone can download it. And if you wish, we could also mail you a physical copy if you don't already have one. And so what this is the prospectus that we normally give out during the open houses. And just very briefly, it has a nice overview of not only what the Bachelor's of Arts and Science degrees is for Design Plus, but also our Bachelor's of Architecture, our Master's of Architecture programs, our Master's of Philosophy and PhD programs. So you can see there is a continuum that's offered also at Hong Kong U. And really also our public program, things that are open to everyone. And we greatly invite you all, even this evening, we have a lecture right after this as well. So in this, you can start to see too what it is that Hong Kong U architecture starts to represent. And we are ranked among the best schools in the world. That Hong Kong U architecture has always been very highly ranked globally. We compete with many of the best schools anywhere on the globe. And really, we are very much also part of a very global system too, meaning that we invite a lot of overseas critics to come into our program, and we also travel quite a bit. And unfortunately, we can't do that this semester. And in it, we also think deeply about how design and research intertwine together. And so there's more writing in the prospectus, but also starts to put our position about what architecture needs to encompass. So it isn't just the idea of design and research, it's also about the history and theory. We invited Dr. Yuna Sang to also speak a bit about the history and theory of architecture, and we'll return to that in a moment. And of course, because we are in Hong Kong, architecture doesn't stop with the building. It's also about urbanism, and it's about how we inhabit our cities and how that changes as well. So there's a lot of focus in our program about urban context that starts to fit within everything that we do as architects. And then there's the technology side too, and how buildings are very technical. They're very artistic, they're very inspiring, but then there's also the structural side and the technical side that goes with the buildings with that. And then of course, the media and technology and computation that's greatly changing how architects design and build today. And we have a lot of robotics, and we've been expanding the robotics side of it. And we have a lot of very advanced fabrication technology as well. So 3D printing and other ways, laser cutting has been with us for decades. And then really the thinking about how we practice and manage within architecture too. So the overall of the program, you can see if you download from the prospectus, that it really does have a deep-rooted idea of being situated in the studio. And it's really studio where you create things, where you make things, where you work collaboratively with your classmates, and of course with the professors, in order to reimagine what architecture could really be. And this idea that architecture isn't just as simple as a building, it sort of expands well beyond the building. And really thinking about the ecosystem that it sort of sits within, and also how it starts to affect and think about really how we start to live. So with that, I didn't want to linger too much on things that you can also download from the internet and read more about within, but this is sort of like an overall brushstroke of what the students do with their time. A lot of it revolves around drawing and making. So our thoughts are really expressed through the drawing and making as well. And I wanted to open up and start to open up a conversation with Dr. Yuna Sang, who not only teaches a wide range of courses that relate to history and also the theory of architecture, but also has her own design practice as well, and starts to really investigate architecture, both from writing and producing books and thinking about architecture, all the way through to also producing and making buildings that relate to those histories. And because of the unusual context that we find ourselves in, I was thinking that the first question I almost want to open up with and really ask is about the current situation that we find ourselves in. what we find ourselves communicating through technology, through Zoom, because we're not in a space that we feel that we can see each other, because there's a global pandemic disease that is then trying to solve by not letting us see each other. And I just wanted to ask a few questions, because architecture and the history of architecture and the way that we work as architects isn't a one-way lecture. A lot of the way we look at the world is actually through dialogue. And so we're thinking today is a good moment just to have a few questions. And I know time is always of the essence. So it's maybe just one or two questions. But Eunice, we were also speaking about the idea that in the history of especially modernism in architecture, in contemporary architecture, there is always this idea that health of the city or health of the building is very important to the inhabitants. And I was just wondering if you could speak a little bit about that.
I just want to pick up on this point, starting with this idea of dialogue. And because the theme here really we're talking about what really is architecture studies, and it's really predicated on conversations, and conversations not in terms of just what we talk about, the content, but how we talk about it. And it goes back to how Hong Kong U as a, I think we're 70 years old this year, as
yes,
a
started in 1950.
That's right, as an architecture school. And if you I'm sorry, Ari, I'm going to answer your question in a roundabout way, but really because of my own burden of thinking through historical moments. But you know, when we started, the first decade was really preoccupied with urban building, because there was so urban infrastructure, tunnels, bridges, land acquisitions, and we will the first generation of cohort was really pretty much building the first generation of post-war building. And if you trace through each very particular moment, it's very integral to how, as a school, we're thinking of thinking through these questions. So to come all the way to the contemporary, I was just sharing with you earlier about a meme that's been going around, that actually architects for the last 100 years, at least we know internationally, have been really preoccupied with the issues of health without necessarily articulating it, global health, disease. And if you look at how the premise of modernism, of being clean, being healthy, sanitization, using concrete, glass, etc., the sort of ideas that are embedded in architects who claim to be modern. It's really thinking through questions of health, questions of how to prevent disease, and etc. So what I'm saying is that both locally in the context of Hong Kong, as well as thinking globally, it's something that we have been very preoccupied with. Of course, it's not limited necessarily to Hong Kong U, but we are extremely self-conscious here, I think. Do you think so?
Yeah, I mean, I think also Hong Kong as a city is really amazing, that the city also, I have to say, there was a lot of the housing within Hong Kong that was also born out of tragedy. In thinking about the fire from decades ago that brought about the whole program in having mass housing. And that it's through these moments that we live through that have a great impact about how we then think and present architecture in the future as well. And that we often think about that architecture, there's a visionary side, which we'll see today too. And I think a lot of the work that our students do, and also that we do as architecture, definitely has a visionary side. But the part about the visionary side is that you also have to have a context to work within. And that it's much more effective to have a new way of seeing the world by, I have to say, having a very specific context to help frame it. And I think in Hong Kong, we have always had a very urban context. And that urban context is something that we've had to grapple with before much of the rest of the world. And now, as more and more of the world is urbanizing, they're looking for models. They're looking for ways of examining architecture. And they're looking towards Hong Kong, because in Hong Kong, we've already been testing this idea of very dense, safe cities. And safe in this case is referring to health in this particular moment, because we are living in one of the densest cities on earth, and yet we still are able to help frame and control an epidemic. And of course, we have to go through a very stringent manner in order to contain it. But it isn't necessarily being the countryside that makes you safe. There are ways that also the city can be made safe. And we think also about the fire that gave rise to the housing, public housing within Hong Kong. So out of tragedy also becomes a moment to step back, reconsider, and rethink. And I think as architects, that's also something that we always have to do, is that you don't just design, you have to frame how you design and why you design.
I think that's a really important point, because I think often I was the same too, going into architecture school, thinking that I want to design this and that and so on. But then you start realizing that, you know, before you actually decide to design that technically in the real world, you don't really get to choose what you design. However, one of the most important and underrated skill of an architecture student, I think, is actually not so much how to design something well. That is a default, all right? You have to do that. But actually how to know the tools and ins and out of managing a project, etc. But what is more critical is what to design. Like, how do you actually be participate in the process in which whether it's a client or government, etc., is thinking about what is needed, you know, what next, and so on. And I think that's a highly underrated skill, but this is something also that we have been constantly battling with, and I think it's a very healthy battle. And that's something I can't claim that for many architecture schools per se, but I know for a fact that that's a healthy struggle we have. And I mean, on that note also, right now, one of the most critical thing is to rethink housing again, because we're all stuck in these things that was, you know, we call housing, and suddenly what used to be promised as, you know, really fantastic, if you're stuck in it for a few months, it's not so fantastic. So how do we rethink this? It's something to look forward to in the architectural study. You know?
I firmly agree. I mean, although we've been building our cities, I think also it's this next generation we must listen to also reconceptualize how do we build and what are the things that we provide emphasis on. And we can already see there's a lot of emphasis on a more sustainable world where the building materials and how we live are much more sustainable. There's an idea too that perhaps a more culturally engaging world, that not every building in the city has to be the same type of building or the same form, that we can also be a much more experimental, and that we also need to question that the things that we receive as ideas aren't necessarily the ideas that we need to get back into the world, that we can interpret them, consider them, and then communicate them. And I think it's that mode of communication which is so vital. And that's something that is so dearly loved about the studio context, that when you learn architecture versus engineering or versus other type of disciplines, that architecture, the heart of how an architect is trained is through dialogue and through communication, through making things with the hand, but also with a mind that looks back at history, looks back at technology, utilizes all the tools that we have in order to then convince a larger audience that this vision is the one that's worth the investment of society in as well.
Yeah, I just, I don't know how we are with time. I'll just add a footnote to like this idea of architectural education, that that the aspect of design. So for those of you who are like thinking that, well, I can draw, so this makes sense. There is, obviously, it's not just that, because I was a terrible artist before architecture school. But then there's also, of course, the technological and management aspect of it. And then there's history theory, and they are really integral. Each one of these, the knowledge and skills you'll gain from each aspect, it's for each of these aspects, it's really integral in the education of an architect. you will see that at certain moments in education, one will be more foregrounded. Often design is the one more grounded, but the strongest designer or a design is one that is extremely aware of its historical context, its premise, as well as know how it's to be built, right, or put together. So, yeah.
I mean, we should open it up for questions.
Sure.
But even on that, I think one of the classes I love, the two classes I love most dearly when I study architecture, one was history, to give a context about how architecture is formed through decades and millennium. It's thousands of years of history. But the other one was structures. And for some reason, the reason I love structures so much was you think that something is impossible, and what you learn is how to make something that seemingly is impossible possible. But also structures had a very creative side about how to make that balance. Ying, is now a good time to take a question or two?
Yes, so I was just going to jump in. Actually, Eunice, you just answered two of the questions that we had
Okay.
by text. One was about the requirements of painting and art electives. Are they advantages for getting into the BAAS in architecture studies? I think you spoke quite a bit about that, but I think through your conversation, I think it's very clear.
Can I add a footnote on that one, though? Is that the thing that will help you most to get into architecture school is whatever your greatest strength is. Though the most fascinating part about architecture is that it's so reliant on so many different strengths. And as long as your greatest strength is something that is very strong, that is the way to get into architecture school. And like Eunice, I actually am horrible at drawing. And I'll be the first person.
Horrible.
Well, actually, okay, sorry. Eunice is good at it. I'm horrible at it. But the reason I mention that isn't because there is this sort of conception that architecture, you need to know how to draw. But if you're the best at math and physics and engineering, that's fantastic. You'll have something to contribute to the world of architecture. If you're brilliant at drawing and creatively solving a problem very, very much by working visually, that's also fantastic. You'll also have a place to contribute to the history of architecture. Yeah. And what we're looking for are people who are intellectually curious, people who are really love learning things and love doing the things that they already are good at. And we're not looking for like 4 or 5 categories and we just check each box and we think, okay, you answer all 5. But if you're really good at 2 out of 5, that's a huge advantage. And so it really is the thing that's amazing about it, the discipline of architecture is it's so reliant on such a wide range of skills, and no one's going to be perfect at any of those like everything. So we always have to rely on one another as well in order to gain the best insight.
Yeah, there are so many types of, if you don't know already, so many types of architects, so many types of architecture, so many types of architecture students. I think you define what kind you want to be. And obviously, to be able to know what kind you do need to acquire it to make your own choices and decisions. And I can't emphasize that what Eric said, curiosity enough. Because curiosity is infectious. And because architecture is a community, you need to infect each other to be of any relevance. Like to be able to actually even get anyone to listen to, say, if you have a proposal for what's going on right now, you have to actually be able to step up and infect someone else to be on board with you.
Great. So we want to thank both Eunice and Eric for the lovely conversation. I think the audience is still quite shy. So we can, I think on the note about curiosity, about the community, I will introduce Roberto, who is actually sitting next to me, but also on his screen. He will be hosting the second panel, where we'll be actually meeting some of those students who are studying with us right now, who are the cohort that is speaking up, who are very curious, who are very committed, and of course, striving very much to do what they love to do. So,
sorry, Ying, there seems to be a question about duration of study. I don't know if you want to take it on. at this moment?
How many? Maybe we can keep that question for the end, if that's okay. I will note that. So how many years of study does it take to complete RIBA Part 2 from Nishi to everyone?
So I think the questions can keep coming and we can
Now.
discuss them at the end, right?
Yes, let's do that. Great. So I pass the baton on to Roberto.
Okay, so I just unmuted myself. Thanks for the introduction, Ying. I am a lecturer at the department. I've been teaching here for several years, and
Sorry, Ying, can you hear Roberto?
Roberto, can't hear you.
Roberto, I can't hear you.
Can you hear me now?
Yeah, perfect.
Right. Yeah, there's a button in my headset that mutes things. You want to unmute yourself? Yeah, so I'll maybe repeat myself. What now?
Much better now.
I think there's still an echo.
Okay. Is there another computer in your room, or is there another?
Yeah, we are sitting. Ying and I are sitting next to each other.
Ying,
No,
you'll
but
have
this is
to.
good.
You'll have to mute yourself.
Right. Should work now. In any case, what I was saying is that it's a good time to introduce some of our students, since the discussion expanded a little bit on how we have different kinds of students, and we definitely don't just have one area of interest per student or one type of expertise. We have quite a diverse group of students. And the objective of this panel will actually be to answer the question, why is Hong Kong U a great place to study architecture? Some of our guests, some of our students have just turned on their cameras. And I'll just quickly introduce you. We have Cheryl from Indonesia, who's a third-year student. Wesley from Hong Kong, also a third-year student. Amanda from Malaysia, fourth-year student. And Phoebe, who is actually an exchange student from the Royal Academy of Art in Denmark. I think our guests are probably very curious to know, why is it that you selected Hong Kong U as a place to study architecture? I think we can maybe start with that, and possibly we can expand a little bit on your answers and see where it goes. Can I ask Cheryl maybe to start?
Yeah, I think why I chose Hong Kong is because I've always known that Hong Kong has a diverse architecture, kind of like setting, and so I was really interested in just going to Hong Kong. So I was looking up like different schools in Hong Kong, and I think ultimately it's like there are only two choices, which is like Chinese University and Hong Kong U. I think what really attracted me to Hong Kong U, I think, is history, because it's the oldest architecture school in Hong Kong, but as well like the different heads of the department that have led the faculty. So I think they're just diverse schools and diverse backgrounds, like for people from different countries heading the department. So I thought that it would really bring an international and just like a different way of studying architecture as well. I come from a country where architecture is very technical. It just doesn't feel like just like one thing. So I think I wanted something that's more experimental or something that's more diverse.
Nice. Maybe for some contrast, I'll pass on. How about Phoebe? Would you mind answering that question as well, since you are an international student just here for a semester or a year? How long?
Just a semester, yes.
Okay, so why did you come to Hong Kong University for one semester?
Well, I think in general, I think architecture is a really great discipline for exchange across, particularly internationally. My school in particular really has a lot of emphasis on going abroad for a semester and really taking advantage of all the different sort of opportunities that exchange offers. And for me, I thought I really wanted to get out of the European tradition. Particularly in Denmark, there's a very strong architectural tradition that sort of takes over all forms of design. And I really wanted to come somewhere that was almost as far away as I could possibly think of, and try and sort of get a gateway into a completely different way of thinking about architecture. Actually, coming here, I've been quite pleasantly surprised in lots of ways by the diversity of methods of design and sort of attitudes, because my academy is very sort of art-based in Denmark. There's a very sort of one way of looking at things, which is great, but coming here has really expanded every sort of, particularly interacting with all the students here has really like expanded how I thought you could think about architecture. Also, I mean, Hong Kong as a city is just a really great appeal, coming from Copenhagen.
I mean, I think one of the things that I wanted you guys to maybe address, and I think you started already, it was somehow how your expectations of the place, in a way, the mental picture that you had before you came here differs from what the actual experience ended up being. I think, you know, thank you for sharing, Phoebe. It seems like, well, this school has some very different characteristics. It's also a very different city. How about we can ask Amanda to answer the same question?
Sorry, about the second question, right? About like our expectations and...
Yeah, I mean, you can either answer why you came here, and you can also expand on that and also tell us how it was different from what you imagined and how it is now.
I'll say I applied on a whim, actually, and I didn't know a lot about architecture at that time as well after high school. But I think the reason what drawn me to Hong Kong in the end was just the contrast with my own hometown. So I grew up in a relatively low-rise, quite an underdeveloped kind of area. So I think when I visited Hong Kong for the first time, like I was really amazed by just the density and the high-rise, like the bustling of the city. So I think that's actually really, I realized that is a very important thing as well, because I didn't expect the city to play so much of a role in studying architecture, but because our projects are all, you know, situated in like mostly in the city that we would stay in or like we study in, like ultimately what we learn in the end would very much be related to how we live in the city. And I think that was very interesting for me, like living in the city that we're designing in at the same time. Yeah.
Yeah, I think that's a very good point. I mean, in a way, for a lot of our studios, the city becomes this lab where you can actually test things, right? And as Eric mentioned earlier, in a way, you know, it was an early experiment in high density. So there's a lot of things that you can learn from your immediate context that I think you guys apply in your courses and take advantage of these things in your courses. Wesley, would be good to hear from you, because your perspective is probably different than anybody else's, since you are actually from Hong Kong, meaning you probably were very familiar already with the city, but still you didn't know what Hong Kong would be like until you came and joined us. So would you like to share a little bit?
Put it this way, I think Hong Kong is a good place to study architecture, because it's somewhere with very dense context. In a way, it's almost like a restriction. Now, restriction might seem like a terrible word when it comes to design, but then architecture is not just about designing whatever you want. It's almost like a very careful, like balancing act of some sort, in which Hong Kong provides a very, like an extensive spectrum of parameters for you to kind of like decide on which one to pick upon. And considering like about the expectation part, before I come into Hong Kong, you actually thought like the school might have a very distinct like education style, like focusing on a very external methodology. But turns out like all the teachers here, they are very, very different. Like some might be focusing very much on like drawing, some might be very technological, some might be very structural and essay. And often like what they say are very like contradict with each other, which is something like the most enjoyable part of studio. Like, because before you come into the school, you might be feeling like, oh, so the teachers in there might have a particular style that they all kind of agree upon, which is not the case here at HKU at least. And I think that's very important, especially for undergraduate education in architecture, that is to kind of like expose you to as many styles and as many kind of like fields as possible.
I'm glad to hear that that one of your favorite things about being here is the contradictions, the contradictory messages. I think that's a very good point, because in a way, as has been discussed already, we sort of we grow and we learn through dialogue in the school. So it's very common for different teachers to have different approaches and contradict each other. Actually, the idea is for everybody to become much more critical and develop their own position. So quite appreciate your comment. I'm wondering if now I could ask you guys a very simple question. If you could offer a piece of advice to incoming students about the department, about the university, or simply about studying architecture, what would it be? Maybe Cheryl, you can start. Sorry, I didn't say who should start.
Yeah, that's a difficult question because there's so many things that that you can learn or that would be helpful.
Sorry to put you on the spot.
Yeah, but I think one important lesson is like growth mindset. I think it's so easy to kind of be, I think in my first year, I think I was a bit astounded or like, I think not very used to taking, as Wesley said, like different voices, speaking, telling different criticisms. So I think, I think like the point in which I think my second year or like first year, second semester, I think I really learned what it means to be okay with not knowing or be okay with making, being in a state of like continuously making mistakes. And I think if I had learned that earlier, I think the process would just, I think there will just be exponential growth because there's so much to learn. And even third year now, and every time we have a review and we invite different critics, they would still argue and they would still not understand architecture as a discipline as a whole either. So I think it's really a humbling experience to know that even experienced architects are still learning from each other.
Evie, would you like to answer the same question, please?
Well, I think Cheryl annoyingly summed it up very well for me there. But I would also add that, you can come from anywhere and study architecture. I have a history degree that I spent 4 years of my life on in my early 20s. And I probably started my degree a bit older than most people do. I haven't regretted any of that, the whole process of doing my history degree, and it has informed my knowledge of architecture, my history of design, history of art. All of those disciplines, they all inform each other and definitely sort of help you to be a better architect. There's no background that you can have that can possibly impinge your ability to be an architect. And it is definitely, as Cheryl said, a journey of growth and understanding that your project is not necessarily, although you've spent a lot of hard work on it, and the criticisms that you're getting are not personal. They're about design and they're about your project and not about you as a person. That is definitely something that took me a little while to understand. But once you get there, as Cheryl said, it's definitely a really great learning experience.
Very nice advice. Amanda?
I'm not sure if my advice would be a bit like on the dark side, but like it's almost to say let architecture like almost consume your thoughts, because I'm not sure, because like for me, like especially this year, I've realized that, well, like it's not like, it's a sudden realization, but it's just like I opened my eyes to the like just the thought of, okay, we are surrounded by architecture. Like just the other day I was walking down like U Street with my friends and we just started like, oh, this space is like 5 meters tall and like 10 meters wide. And it's just this little things that you just need to start and process, like for example, why you like a certain space, or like how you like certain spaces to be like, and all this translates ultimately into your designing. Because if we live in if we live in literal buildings, like why are we not taking what we do or like what we think about those buildings and applying into our design? Because too often we see our designs from like a bird's eye view. And I think it's just really to get like almost like like very hands-on and very like dirty with the design. But that's for me at least.
No, I think that's a good point, because I mean, all of us are exposed to architecture for years, if not decades, before we actually go to architecture school. So in a way, we already have our preconceptions, and you know, being able to learn about architecture, it's not something that you start at from scratch, right? So it is, to some extent, also a relearning process of sorts. Wesley, how about you? What piece of advice would you offer an incoming student?
My piece of advice is kind of specific. Other than doing architecture studies here at HKU, I'm also doing a minor in computer science. But it's actually not that good of a decision, like looking back. It kind of extends to another point that I want to make. Not because like it's too heavy academically, but because doing a minor in computer science kind of like inject a certain kind of bias in your mind. And how do you think is kind of like specific. And the same case is not just for computer science. It's more like don't try to like learn a specific software to feeling like, oh, I'm gonna get ahead of my classmates before entering like the architecture schools. Like come in like as clean as possible so that you can learn as much. Because once you have a certain kind of a premise about how the subject should be or how you are gonna use a very specific angle in architecture, in my case, I feel like, oh, I'm gonna do it very computationally. Your mindset will be very much like trapped in your own like bubble, and it's hard to get rid of that. So come in as clean as possible. And history on the other side is something different because it's always open for debate. And read more about history, perhaps about more the humanities side. And don't try to get like too technical. Not saying like it's a bad idea. Just as mentioned before, for undergraduate studies, you should be like prepared to get exposed to as many as possible instead of like drilling of a specific angle.
Thank you, Wesley. I think we ran out of time for our panel, and I think we're going to move on to the next one. Thank you so much for your contributions.
Maybe I unmute.
Yeah, go for it.
Great. So thank you all for joining, especially to our students and in masks as well. Before we move on to the future, which will be hosted by Thomas, I wanted to just categorize the questions that have come in very quickly. Some of you are very curious about how to get in, you know, both for transfer students as well as undergrads. Some of you are very curious about the program in of itself, what it contains, and I think what Eric shared in the very beginning, our prospectus, actually gives you a very good picture of what the courses, the curriculum, the makeup of this, the course structure is about. And then some of you have asked about some special things like study abroad opportunity. That is also something that probably in the third panel, also from some of our grads, as well as this current panel, they may have answered some of those questions already. So we can still address some of those if they're very, very urgent. But I think without further ado, I will pass on the baton to Thomas and his panelists.
Thank you, Ying. It's a pleasure to see you all, and also some of the class from the year 3 who just spoke earlier. So this panel this is focused on what is our future after BAS. And so I would like to present a couple images what we're doing right now during at BAS, and also I'm going to invite 4 guest speaker who's a graduate from the BAS program, and I will later give a little introduction. But in first hand, I'm going to go ahead and show, I'm going to share my screen. Yeah, can you guys see it? Okay. Okay, I've been teaching here at Hong Kong U for about 10 years. Before then, I taught in New York at Cooper Union for about 2 years. And so after 10 years, now being a permanent resident, I feel suddenly beginning to feel at home here in Hong Kong. So I'm gonna show you some of the things that we're doing this year. This is our current class for year 3. We have about 68 students. 2 are actually from exchange. We have Phoebe from Copenhagen. And I'm going to show you a couple of things. And this is our current work that we've been focusing this semester, looking at the legacy of the work of John Haydock. And I'm going to show you couple works of students' work from current this semester. And you might check out your volume because it might be very loud.
Station built by U.S. Navy becomes nerve center of Radio France as U.S. government turns this gigantic transmitter over to French. Now France will have sending and receiving station in new world of sound. Monsieur Deschamps.
These short radio waves travel only in a straight line and cannot follow the Earth's surface. Therefore, the limit of television is the distance from the antenna to the horizon. From the Empire State Building, a program can be sent only as far as the eye can see on a perfectly clear day.
And this is Cheryl's work, the students you met earlier from Indonesia. Can you guys hear the audio fine? Okay. And this is Wesley's work. And this is Phoebe. So the work that I just showed you was the first 5 weeks of the semester when we were told that we were not coming back and that the whole studio teaching was going to go under completely online. We thought one of the best way to respond is that students should continue build physical models and ask them that the physical models made into an animation films. And I think these films also kind of thinking about their personal spaces and how they work, because all the things completely change. So the work that we saw, the work by the students just now, they were all in their studio at home, not the studio that we had before. So this is what semesters look like. And this is the first semester when we had everybody all together and coming together. You could notice that we are obeying physical distancing, definitely very social. But I'll show you something that we did last semester. As well, we were all together. We had a workshop with a professor from Perry Kopler, and where we actually start to develop a work modeling only through digitals. And I'll show you some of the works that's being done. And this is only a 3 minutes film. This week, we had an opportunity to bring Perry Kopler, the inaugural artists in residence or architects in residence at the Department of Architecture in Hong Kong. Gives an opportunity to develop a masterclass working together with our undergraduate year 3, along with our graduate students, together with also Chelsea University.
So the interest for the workshop really emanated from worlds that are more homogeneous or schematic. I was interested in trying to let the students engage worlds that might implicate other worlds as a result of worlds that were often that are stripped of multiplicities or other kinds of lives. So that was part of it. The other part of it was to try to figure out how to work with appropriated things that have to do with that we find in my productive use as a way to initially get momentum, get thickness in those by appropriating other things, and then finding out how they might talk to one another, rather than starting from blank slates or like the black screen of a
This workshop has kept me incredibly fearful because unlike other studios where they give you background, I am responsible for the content and the context, and he is very adamant about preserving the scaffolding and designing the structure to which I place the content.
Compared with the architecture training in Taiwan, we have really different and free experience here. Because with the digital tools, we can represent
Well, anyhow, I thought maybe we could just go through the panel because these videos are also available on HKU website. I'd like to invite four guest speaker. We have Michael Hendricks, actually based in Singapore. He graduated in 2014. Yenchen Liu, who graduated in 2012, currently is a lecturer at China Academy of Fine Arts in Beijing, and Su Chang, a lecturer at Hong Kong U, and Yigu Wu will be joining us from Berlin, who graduated in 2015. I'm going to go ahead and start with Michael. Michael?
Hi, hey guys. Yeah, so I completed my architecture degree in 2014, and after graduating, I decided to kind of take a different direction, and I decided to work in user research and the digital space. So through kind of bringing architecture into the digital space, I've kind of always tried to bring that studio practice that I used in HKU. And I think like Eric mentioned and Thomas mentioned, that deep investment in learning and kind of like through making and doing and creating and kind of hands-on research. That's been a lot of what I've taken from the program and even applied to what I do now, which is digital interfaces. So kind of installing installations in a site specific. Now I translate that into how I design my kind of digital interfaces or digital experiences in my work now. Here you can see me doing some work in the studio at HKU, and then also a research trip that we did in China to Guangzhou to kind of understand that context. Before HKU, I came from Tianjin, so my parents moved to Tianjin when I was in middle school. So I did my middle school and high school in Tianjin, and I think the changing landscape of China also brought that background to me and the way I approach architecture and the way I approach the future of my work as well.
Thank you, Michael. Yanchen Liu. Well, anyhow, if she's not here, Yanchen graduated, as I mentioned, 2012, and she pursued. Oh yeah, Yanchen, great.
Can you hear me?
Yes.
Oh, okay. Oh, hi, everyone. So, so I graduated from Hong Kong U in 2012. I'm currently teaching at Central Academy of Fine Arts, the architecture school. So I've been teaching here since 2017. Yeah, and before I came back to Beijing, I went to Boston, attend the Harvard Graduate School of Design. So this photo is me and my students. So this is 2 years ago. So we were doing a construction workshop in Beijing, and the students developed a installation using plastic cap. And I remember that it was a very windy day, and the whole structure almost blew off from the ground. So the number 2 from the right side was me, and Thomas just told me that like we look almost, I look almost as young as the students. So, and then the next one, Thomas. Great. Yeah, so this one was almost right after I graduated from HKU. That I was very honored and to have this opportunity that I can build a house for my parents. So this was the first time that I saw the basement was poured, the concrete was poured. So I was standing on top of the concrete floor, freshly poured, and we saw the charcoal lines imprinted on the ground. So that was from my my plan drawings. So that was the first time I saw my my design was imprinted on a real space. So I was very scared because I knew that I must have made a lot of mistakes. Yeah, but that was in almost 2013. So 1 year after I graduated. And the next one, Thomas. And this photo was taken in Switzerland. So that was in about 2011. So I got this opportunity to be in an exchange program at ETH Zurich. So I was in Zurich for 1 semester, and then that was the time that I traveled a lot in Switzerland. So sometimes by myself, So this photo was taken me cycling myself in the mountains of Switzerland. So I remember that I was in a tunnel, and the tunnel was very dark. And then suddenly I saw a light coming from a side. So I took a photo with my bike, my backpack, and also the city underneath. So that was my most memorable experience in Switzerland. So that was also for HKU, I spent 1 semester in Switzerland, 1 semester in Shanghai. So Hong Kong, and also 2 years in Hong Kong. So that was my whole undergraduate years, that being everywhere around the world. Yeah, so that's it.
Sorry, I put actually a caption Amazon, because I know that you also spent 1 summer independently in the Amazon forest doing research on science. Because you thought that maybe you got sick of architecture. I thought you decided to go to the forest. And I thought this was the tunnel inside the cave from the forest. But yes, it does look a little bit less like.
It doesn't matter.
I would say.
Doesn't matter.
Thank you very much. Su Chang?
Hi, I graduated from HKU's BA program 7 years ago. And then after my master's study, I'm now currently practicing architecture in Hong Kong, and I also had the opportunity to engage architecture through by way of writing and translating and editing text. And this is one of the books I finished translating last year, and it was published last year. And what was amazing that I think it was a book first written in Spanish, but later got translated into English, Portuguese, Italian, in Chinese, and how the idea about living and the good life could be shared across cultural boundaries and borders. And I think I also like Yan-Chen also benefited from my study here at HKU by really had the opportunity to travel and see architecture in different places and different cultures. I also spent, Thomas, if you can, yes, I also spent a semester in Zurich, and then I was able to not only experience architecture, great architecture in person, but also to see some of the drawings and read some of the text by these architects. Like this is the basement of a house by the great Swiss architect Le Corbusier, and really see his real, his own painting and drawings on the walls. And then also that, helped me understand architecture to be something that's more than just building, and that there's also a culture aspect of it. And before HKU, I always thought I was, gonna study trees. And I thought and now I look back, I feel like I can also see architecture as something that's, like a living organism that's many layers and has its own core and branches. So I think it's totally different from what I pictured before entering HKU. I really appreciate had the opportunity to look at architecture in different ways.
Yeah, Su Chang, I thought you were actually a reason why you decided to go to Switzerland for exchange, because they have a profession where you do count trees. So I thought you want to join the key counting club on the weekend. So okay, this is actually before. So in Hartley, where your sort of destination would be. I would like to invite Igo Wu from Berlin. As Ego is joining. Ego is a rare phenomena, because usually most of our students, 90% of our students play musical instruments, and they decided to either study law or study medicine or study architecture. But Ego is somebody who actually studied architecture. Later, after he graduated, realized architecture was not it. So he wanted to carry some of his background understanding into music. So right now he's working as a composer and pursuing a study, Master of Arts in sound studies in Berlin. And this is some of the installation performance that Eagle has done at the Hong Kong Academy of Performing Arts. We actually used the building as an instrument, and he choreographed and compose sequence of musicians at different platforms, also the elevator, the escalator. So he actually used the mechanical of the auditorium. If you've been to APA, you probably realize is a stage in itself. And he took an opportunity to perform the building. And during when he was HKU, he was a contractor. No, this is not a contractor. He was we got a chance also to went up to several of the trips to where we spent 1 week building an ancestry hall in outside of Guangzhou. And you can see that yes, that's Eagle, and this is what Eagle did before. I don't know, maybe somebody wants to translate it or such, but you can see this is something that he done before. Okay. All right, so this is the end of things, and so I'll just bring up the slides. Ying, how are we doing with time? I know we have a lecture going on.
We're running a bit over, but I think we started very much discussing the importance of a dialogue, of conversations, of exchanges, and I think it's very beautiful to see. Actually, Thomas, you're the one who came up with the title of the series, calling it before. What is it now? Present. And the future. So ending on the future also gives our audience a sense of what happens when all of you finish a degree at the BA's program at Hong Kong U with us. And you can see that the community, doesn't just end with the degree, with the kind of adjournment of the series of studies, but that it's a community that we're building in a way for life. It's a community of curiosities, of interests, of shared values, and of kind of things, common things that we all cherish very much. I think for the sake of time, maybe we wrap up so that we can ask invite also our audience as well as our guests to also join tonight's lecture series. We know that for most of the students who are applying, who are looking to apply in the coming years, that choosing a university, choosing a major is a huge choice. There is no wrong path. This is also why we wanted to share with all of you kind of our values, how we discuss, how we talk, and who we are. So I wanted to also say that it's not the end of the world if you don't make it to join us for the undergraduate program, that we actually do have, starting from last year, a 3-year Masters of Architecture Design program that I will share a final link with you on. So should you choose another major, you still have the opportunity to study architecture at the master's level with us. And this is definitely a new opportunity in all of Hong Kong. And that means you can always join our community. So maybe with that, I will share the final link with all of you and invite all of you to join us for the public lecture that will happen.
Thank you, Yan-Chen. Thank you, Su-Chan. Thank you, Michael. It's great to have you back, even though you're probably far out doing some of the exciting work, and you're contributing to into emerging field, because I think that's very important as Michael is developing type of residency project, and also Su-Chan writing and developing books, because also there's a very great strong leaderships for developing written text into the discourse in architecture. And of course, Yan-Chen is building a group of artists coming out from China Academy, a prestigious school from in mainland China. Great, thank you very much. I just want to ask you, if you could say one word from your experience, what would that be? Su-Chan, what would that be?
I would say surprise.
Surprise. Michael?
Invigorating.
Okay. Yan-Chen?
It was hard.
You make it look so easy. Go.
Hi,
Go ahead, Igor.
Mind-blowing.
Okay, a composer says mind-blowing. I think it's completely silenced. Thank you very much.
Thank you all.
Thank you.
Thank you, everyone.
Great. Thanks to all our panelists who joined us, and thank you to the audience for joining us. Great. So I think this is actually the very last session for the day, right? From Nicole.
Yeah. So Dr. Zhao, I'm just wondering, like, just now we have very fruitful sharing on, you know, our expectations for architecture program and also, you know, life after doing architecture. I'm just wondering if you will take some questions from students, because perhaps some of them, like some of the prospective students here, they may be concerned of how are they tested in the aptitude test. Because personally, as a counselor, I receive a lot of questions on the aptitude test, because maybe I'm wondering if you can like share a bit on that.
Well, maybe we just say one word about the aptitude exercise. This is a one-time opportunity. It's not a test we think that students can prepare for in the way that you prepare for an exam, for a physics or a math exam, or even a writing exam. There is no right answers. And so in the sharing of this exercise, we're showing you the way that we work in our department and in this discipline that is very much project-based. So in a way, we're sharing a method of working that is about how you see the world, how you want to see the world, and how you develop that. So that's also why the aptitude exercise every year is not the same. So if you studied very carefully last year's, it will not help you with next year's by any means. So these questions are very open-ended. We're actually trying to kind of communicate with you through a visual format, largely visual, but also some text could be included. That shows a way that you respond to this open-ended question. So this is also how architecture as a discipline works very much. You heard from Eunice and Eric also earlier that to be a super skilled drawer does not guarantee that you'll be a great designer. Conversely, being a very good drawer does not stop you from being a great designer. So for those who are concerned about arts education, about visual education, of course, if it's something you're passionate about, you enjoy, you love, that's all the better. But I think one thing, do not worry if you feel like you can't draw well enough, you have never taken a painting class, we will teach you. This is what we're here for. If you are already an architect, then you don't need to come to our program. So don't be concerned about that. But be curious, be interested, be invigorated. I think you see from our students, both past and future, not future, but past, present, future. Yes, we're looking for people who are interested in our community, who want to join because you see that we're a good fit, that you want to take part in these conversations. You want to be the ones asking questions or the ones answering questions. I think that's the most important thing.
Yeah, sure. I have another question, which is I'm always asked is whether you have to submit a portfolio. Like, does the portfolio help you at all? Because I know on the website it clearly says that.
It's not a requirement.
Yeah, it's not a requirement, but like students are not convinced. So how about like?
By all means, send us anything that you would like. If you wrote a novel, if you composed an amazing piece. I mean, for us, we want to get to know you. And this is also why the exercises are our way of telling you how we think. It's a two-way situation. We are maybe somewhat more open-ended than some of the other programs, exactly in the sense because all the exercises you will be doing in studio and design studio in your seminars and your classes are all similarly open-ended. So there is not one single solution, and this discussion is extremely important. So please support, if you have a portfolio, send it to us, show us who you are. I think that's the most important thing. If you're good at making, I don't know, you're a jeweler, and this is something that you really enjoy making, or you are extremely good at gardening, tell us in any way, form, or possible, so that we know this aspect about you.
All right, so from the chat box, there's one question. Is digital modeling becoming more important as compared to physical sketches? Will architects seek opportunities in virtual views?
As we emphasized in the beginning, architecture is finally a very physical world. We're building buildings. Some of us, not all. Some are definitely going on to building virtual environments. So the virtual cannot exist without the physical, because virtuals are simulations of the physical. So to answer that question again, I'm answering a question perhaps with a more questions that there is no dominant way of design, of our putting forward propositions. And our students also come to grapple with this very much, especially you saw with the videos that were produced in this semester during the epidemic. Because we are not able to gather in our studio space, we're not able to be together, that we find other means to try to, in some ways, compensate, to play on the strength of how to still understand space, even if we can't be in it physically.
There's a question on
there is no failure compared to other students. We are judging you against yourself. I think that's another question. This is exactly why we introduced the aptitude exercise, because we realize different schools teach different things. Different students have different opportunities in terms of drawing, in terms of access, in terms of resources. So you don't fail if you don't have a portfolio. But if you wish to share some of those drawings with us, and do it in a format that allows us to see it. So there is no standard format. The only thing we ask that all of you do is to take part in the exercise unless there is extenuating situations. We know there's been so many extenuating situations in this year. We understand that.
So would you still take some other questions in the chat box?
Yes, so Hong Kong, Australia is a good place for architects to work. I think these kinds of questions, I mean, we can have another panel about this. What does good mean? What kind of architect do you wish to be? I think, you know, places change, as we saw very quickly. Places that look very safe suddenly became very unsafe in the matter of weeks. Places that looked like they were going into, you know, economics troubles suddenly became places that were economically more advantaged. So these are bigger forces that we cannot, you know, predict. So location-wise, I think the more technical questions about scores, please refer to the Hong Kong U website for the scores for the SE. So there are cutoffs that are available on the Hong Kong U website, so you can look those up.
Yeah, and I'm posting the link in the chat box now.
And for those who are JUPAS applicants, we will be getting in touch with you soon. Yes, so don't be stressed out if you haven't gotten anything, because we have not sent anything out for the JUPAS applicants yet.
Right. So I think we're almost coming to an end for today. So I'm just wondering, is there a channel for students to ask any questions? Like, is there an email or a link on the website? So
I think you can send we usually take questions, especially from potential applicants, through William, who is our administrator for undergraduate application. So, and also Ivan, who is piping in right now. So, yes. Ivan, maybe you, yes, say something so that everyone can see your email.
Okay. If you have any technical question about admission,
Please send an email to Ivan Wong, who just spoke, and his email is visible in his.
And alternatively, because you can also send a message to like Central Admissions Office, where the link I'm sharing now. Yeah, either you can write to willow@hku.hk. Questions in the link I just provided. Okay.
and also my.
Yes, Ivan.
Ivan, you just spoke.
The echo is terrible, but you can write to William or myself, and you can see the Zoom. My Zoom link is actually my email address.
Yeah, so everyone, I think like you can check the chat box now, and then you can see all the links and the emails that you can write to. Right? I think they will like more than happy to answer your questions.
Please take the links that I also sent out very seriously, because a lot of the questions may be already answered in the prospectus in terms of the number of years, the actual study structures itself, and also the opportunities, for example, for overseas exchange. We have detailed those very, there's been a lot of thought put into the prospectus in order to communicate that information to all of you. So those, please have you can download it. If you would like a physical copy, we can by all means mail one to you. So you can write to us and say, I would really like a physical copy because I don't like to read it online. But a lot of the kind of details of our program are in the prospectus. I think in terms of comparing our program, maybe I just say one last thing about comparing our program to other programs in the world. We can do a lot of benchmarking, etc. There are not that millions, but thousands of architecture programs that students who wish to study architecture can choose from. Hong Kong U is one of the top ones in the world. I think you can see that in the rankings and the numbers. But I think more importantly, it's really about whether you feel our community is one that you wish to join beyond rankings. And that is something that we also communicate very strongly during our interviews, that we would like to work with students that we feel are a right fit, and you feel we are a right fit. So, it's a 5-year program, it's a 4-year program. Those are all technicalities. You have a number of issues like location, like resources that all of the parents as well as students can compare. But finally, it does come down to what can we offer you, and how can you contribute also to our community. So we can't emphasize that enough.
Mm-hmm. Yeah, I think it's a good idea. A very inspiring virtual open house. Nice. So I think it's a very good idea to always check the website of the HKU Department of Architecture. So I think like with all the channels provided, you have like you are in good, like you have good access to for help. So I think that's pretty much for today's session. Yeah, thank you very much for
follow us on Facebook, Instagram, WeChat, we're everywhere. So
yeah, sure, Facebook and Instagram. So I think yeah, that's pretty much for today's session. Yeah, stay in touch with us, and we hope to see you soon in HKU.
Okay.
Thank you everyone for joining. And please join
everyone for joining
our lecture if you're interested in more conversation.
Yes. Yeah, conversation. Sure. Thank you, Dr. Zhou, and all the panelists. Thank you very much.
Thank you, Nicole.
Thank you.
Thank you. Bye-bye.
Bye.
Bye.